So, welcome everyone to today's webinar. The webinar is organized by the Happy to Help group. I have sent out the website on the chat window. Our topic today is basics of cloud architecture, and the speaker is Mr. Ganesh. Ganesh is, a distinguished engineer with Rackware, but we also, have the I think fortune of having him as one of the founders of Happy to Help, and also he is part of Digital Space, another startup that he has founded, along with a couple of people on this call. So, extremely talented technology, I would say professional, with a very vast understanding of cloud infrastructure. So I'm sure the talk is going to be quite informative and kind of buzz some of the jargons around some of the terminologies that are used, and we are trying to keep it at a basic novice level this webinar, and depending on how the I suppose the feedback is we can delve deeper into individual topics as required in subsequent webinars. So hoping to have a very participatory conversation today in the next hour. Please feel free to use the chat window to raise questions, or you can unmute yourself and do that. So over to you, Ganesh. You can start.
Thank you, Atul, for such a nice introduction, and thank you all who all are joined today. Uh, I'll just let you know that this session or webinar will be on very basics of cloud architecture. I'm not sure from which field or from which domain you guys are. Probably few of you might already know everything that we have here, but yeah, feel free to stop me anywhere and let me know if you need more details on that, and we can go and dig deeper, or like Atul mentioned, we can dig deeper in the further sessions or webinars when we can conduct on the cloud architecture. Yeah, with that basics, I'll just get started. Yeah, so yeah, and feel free to stop me anywhere and we can have a question answer there itself, or we can have a question answer at the end of the session as well. Okay. So this is the agenda for today. Uh, Basically, we are going to cover very basic introduction to cloud architecture, then cloud service models, then cloud types, then cloud providers, then whatever cloud providers I mentioned, we'll do the comparison between the top three cloud providers or three core providers, and then the second last topic is a core cloud framework, basically what underlying stuff is below the cloud. So that is basically a virtualization, and we can dig deeper there what exactly virtualization is and how cloud interacts or works in real world, that we can discuss. And the last part is current cloud market. So basically that topic I kept for the people who really are very beginner in the cloud domain and they want to really understand which cloud they should learn, or people generally do courses in multiple clouds, right? So this last topic will be helpful to understand which cloud is currently in market doing good, and which cloud they should choose for their courses, or increase their domain expertise in that particular cloud. So with that, I'll start. So basically, any any cloud is basically has some certain building blocks with it. So before going to a cloud itself, I'll ask a very basic question. For any computer to run, do you guys know what are the basic components that we need? And guys, please feel free to unmute or put it in the chat, and let's have an interactive session, right? So my question is, what are the major components any computer system consists of?
Yeah.
Anyone? Hmm.
So Ganesh, we need a CPU, we need a memory, which is RAM, and
Hmm.
then we need a input output, meaning
Hmm.
keyboard and mouse could be the input, and monitor could be the
Hmm.
output. So yeah, these are the sort of basic building blocks, I would say.
Okay. Okay. And when I talk in terms of yeah, this is the correct answer, Om. And when I talk in terms of basic components, generally anybody can divide those in three basic things. One will be a compute. So like Om said, compute will consist of a CPU and RAM of any machine. So whatever the compute power to run the applications or OS on top of it, we will need a compute power. So that compute power is nothing but a CPU and RAM. Okay. The second part is storage. So whenever you want to boot your OS from, you need to have somewhere that's stored, right? When you start a computer, it needs to launch OS from somewhere. So that part is basically a storage. So there are various types of storages available in the market at the moment, but this is a basic building block of any computer system that we, whether it's a physical machine or a virtual machine, it doesn't matter, but you will need a storage to have somewhere store the OS as well as the other parts of your applications. Okay. And the third part is these two can have a local computer system running and you can do access and everything, perform all the things, install applications. But if you want to connect to the outside world, then you need one more basic component, that is a network. Okay. So these are the three basic components of any computer system that are needed to have it running and accessible over the network or internet or across the globe. Okay. So so this is what, how generally a physical, if we talk about the physical machine, it generally consists of these things, right? If you look below, there is a NIC and CPU and disk and memory. So NIC is basically nothing but covering the network component. Then CPU and memory is basically CPU and RAM, which covers the compute component, and disk is nothing but a storage basically. So, and once we have all these together, then we can run operating system on top of it and run applications as we want. Similar is the case with the virtual machines as well, but here there is slight difference. Okay, this is everything running on top of a hardware, and hardware is here basically the disk and then CPU, RAM, and NIC card. Okay, but in case of a virtual machine, there is slight difference. When we say virtual machine, there comes one more layer in between called as a virtualization layer, which divides your physical hardware resources like NIC or disk or CPU RAM, divides among the multiple operating systems that are running on top of a hardware, and those operating systems running are nothing but we can call it as a virtual machine. And on top of those virtual machines, then we can deploy our application. So your single physical machine can convert it into a single virtual machine like this. Applications will be running and operating system will be there, but those are running on top of one virtualization layer that is built on top of a hardware. Okay, I hope this covers the very basics, and this interprets what is physical machine and what is virtual machine. If there are no any questions, then I'll proceed further. Okay, I'll move. Then this was in general comparison between physical and virtual machine. Now, when we really talk about cloud and cloud infrastructure to be hosted or to be deployed somewhere, then there are basic components of a cloud infrastructure that we need to consider, and those are basically hardware. That is first part. Hardware will
So,
cover.
Ganesh, there is a question from Soham. What is the need to use a virtual machine?
Okay. So thanks for that question, Som. I'll try to briefly address it, and we can again, if you have more questions, we'll take at the end of the session. So the need of a virtual machine came in when, say, for example, I want a 2 GB RAM, right? And I want to run, say, 4 applications, 4 or 5 applications on top of it. So I'll just deploy a physical machine and I can start do with 2 GB RAM and everything, right? But tomorrow my requirement increased. So requirement increased, so I need one more physical machine to deploy or to have at my home, and then start configuring application and OS and everything on top of it. So in today's world, there are lots of things people need, and they can keep on increasing their workload and everything. So to manage the workload using the physical machines, it becomes difficult because every time you need to have a new application, you need to procure the hardware first, then do the configuration and all that. But when it comes to virtual machine, you can have very one large big configuration physical machine, and on top of that you can configure the virtualization, and then distribute that hardware or share that hardware that you have underlying physical hardware among multiple virtual machines, so that You can have a same hardware but deploy multiple machines and deploy multiple applications as your need increases. I hope that addresses your question. And if there are any questions, let me know. Otherwise, I'll take uh, the
Yeah,
next.
I think so. Yeah, you can go ahead.
Cool. Thank you. So hardware, in case of a components of cloud infrastructure, if I want to deploy a cloud, basic components that I need is one is hardware. Hardware will be consist of actually your network wires, your switches, and everything. Like if you consider any cloud's data center, like take an example of Amazon, say Amazon AWS has a data center in Bombay. So in Mumbai, they have a hard actual lab where they have racks of storage and then wires connected to each other and then switches to do the stuff and routers to route the traffic and everything. So this parts comes under hardware, and then the remaining parts are like storage. Like I said, for your actual virtual machine to run, it actually has to connect it to somewhere real storage. Those will be nothing but the storage racks inside the data center deployed somewhere in across the globe. Okay, then next part is network is basically there are two parts like actual physical wires, NIC cards or routers or switches will introduce a virtualization layer and then virtually manage the network by using the underlying hardware of actual switches, routers, and the cables. Okay, so that covers the network part. And then like I said, this is the main component of any cloud infrastructure. You have a hardware, basically CPU and everything. You have a storage and you have a network. And by using these three components, you are virtually connecting them each other or sharing or distributing across multiple resources or multiple OSs to consume that type of hardware using a technology called a virtualization. So these are the four basic components that any cloud can have, and we can deploy cloud infrastructure by using these four components. Okay. I think I'm done on this slide. If there are any questions, I can take. Otherwise, I'll move on to the next slide.
So Ganesh, Divyansh here.
Mhm.
So virtualization can be said as a software which handles all the resources of the computer.
Yeah. So actual hardware management is done. I have a separate topic or slide on this virtualization. So when we go dig deeper, at that time I'll answer this question that you have. You're basically you're correct, but I can explain in deep basically what your suggestion or what your point you put in. That is correct, but we can discuss that in detail when we go to the virtualization slide. Okay.
Okay, okay.
Cool. Thank you. I'll move on. So our next topic is a cloud service models. So I don't know how many of you know about the cloud here who have joined the session, but if you guys know any cloud service model, can you tell me what are the cloud service models that are currently present in the market? Can somebody answer that?
Infrastructure as a service,
Mm-hmm.
then platform as a service,
Mm-hmm.
and software as a service. I'm
Yeah.
doubtful about this.
Yeah. Yeah. Thanks for your answer. You're correct on that. So yeah, those are the basically I'm gonna compare your actual physical on-premises machines with the cloud service models they currently provide in the market. Okay, so in today's world, if you are hosting a physical machine on your home or at your lab somewhere in your company, so if you look at that, everything needs to be managed by you, right? You will procure the hardware from some hardware company. You will have physical hardware like CPU, RAM, NIC, and disk there. Then on top of that, you can either deploy hardware hypervisor, or you can directly install the OS and configure the applications on top of that, right? Even if you on premises, you have only a single hypervisor. So hypervisor is basically nothing but a virtual machine monitor. Okay, that is basically monitoring and managing the multiple virtual OSs or virtual guest OSs basically on top of a hardware. So on premises, generally people deploy ESX or KVM or Zen hypervisor, or today Microsoft also have their own hypervisor called Hyper-V. So those kind of hypervisors are installed on top of a physical hardware, generally in on-premises environment. and then on top of that you configure your OSs and the applications. This is on premises. But when you go to the cloud market, then there are basically three types of service models generally cloud provides. The first one is infrastructure service, right? So, right, someone said just now that infrastructure service, yeah. So that is one service model. So I'm going to compare this with on-premises. In on-premise, you have to manage everything, right? But when you go to the infrastructure, then comes a cloud provider who will manage some part of it, and you need to manage some part of it. So what that part is? Basically, if you look here, the hypervisor and physical hardware, the hypervisor and physical hardware is managed by the cloud provider. But what you need to manage is you can install your own OSs, you can install your own applications and manage their data on your own. So this is nothing but a infrastructure as a service, right? Then the next service model is a platform as a service, like somebody said. And in platform as a service, basically, if you look at the stack and comparison, we are moving upwards, right? In on-premises, we have to manage everything. Now in infrastructure, we leave hypervisor and physical hardware to the cloud providers, and we are only managing OS and applications, right? When I move to the platform, in platform I move one layer up. Now OS is also not managed by me. So OS, hypervisor, and physical hardware is basically managed by the provider, and I am as a user or end user, I'm only managing my own application and data. So in further slides, I'm going to give you the example of each of these service so that you can relate your day-to-day applications that you are consuming right now in the market or in your companies. You can relate that application is coming from which service model, because most of the services are online now and accessible over internet, but they are categorized between these multiple cloud service models, and all of the services are generally deployed on the cloud. There are very few or rare applications, I would say, will be on premises. If you want to host a service for certain things, you definitely need to go to cloud. It's just that you fit in a certain different categories, like here infrastructure or platform. And the third one, someone rightly said, that is a software as a service. In software as a service, you are not managing anything. Everything is managed by the cloud provider. Physical hardware, hypervisor, OSS, and on top of that application, everything is managed by the cloud providers. So basically, these are the basic cloud service models, and we are going to dig deep in each of the types. Before moving on to that, anybody has any question? Okay, I'll take that as a no, and I'll move on, and we can discuss further again because we are going to dig deep into this each model. Okay, so let's consider first infrastructure as a service. So infrastructure as a service is nothing but any cloud provider currently in the market. You can take an example of AWS or Google Cloud or Microsoft Azure, something like that. For each of the infrastructure services, you can deploy your own virtual machines, and general term to call them as a instances. Basically, for any cloud, if you deploy a virtual machine, they call it as instances. The purpose of this is basically you can have your own cloud account, but you can keep your instances off or deleted, and you can on demand provision instances and start using it. That is the basic purpose of infrastructure. So they have provided you the underlying hardware and everything required in place, and you can on demand create a virtual machine or instances as per your requirement. Here, the benefit of having infrastructure as service is, like we saw in the previous slide, the only all the parts are managed by end user. Only hardware and hypervisor is not managed by end user. Rest of the things, like you can choose your own OS. So like certain people have applications that need to be deployed only particularly on Linux machines, like servers, Linux servers. Some people have Microsoft SQL servers, right? They want to deploy in only particular Windows OS, like Windows 2K16, Windows 2K19, something like that. Okay. So that choice is left with user here in infrastructure as a service, so that people can decide what they want as an end user, and based on that they can select the OS and go ahead and deploy and start using it. So that is the advantage of using infrastructure as service. But the problem here is basically when we own that component, like deploying OS and everything, then it becomes a responsibility for the end user to do the configuration and management of OS, like installing updates and covering the softwares and adding software that we need, or installing software that we need on that OS. Like for example, Microsoft SQL Server I talked about. I can install a Windows 2K16 OS, but if I want Microsoft SQL Server installed on it, then I need to go ahead and do that as an installation. So that responsibility comes to me when I want infrastructure as a service and MS SQL as a server. Okay. And most of the cloud providers today provide their cloud services or expose their APIs, basically application programming interface, to automatically deploy the VMs and everything. We can consume those exposed APIs and do the programming to automatically deploy the instances on demand for end user. These are the basic advantage, I would say, or profits or benefits of infrastructure as a service. And there are multiple cloud providers in the market, but I am listing here the major ones. Like if you know, Microsoft Azure is one of the giant cloud provider in the market. Then Amazon AWS. EC2 is basically their compute service. So compute is nothing but a deploying instance. That's why I named it as Amazon AWS EC2. And third one major is a Google Cloud Compute, basically a GCP cloud platform where you have their resources to be deployed as per your requirement and consuming that service as an infrastructure. Okay. And the benefits of having an infrastructure as a service is you don't need to worry about the hardware. Everything is taken care by your cloud provider. You just need to choose your cloud provider and they'll make sure that underlying hardware is taken care of. You just need to go and launch your instances or virtual machines on demand. Okay. And the benefit of using infrastructure as service is take an example as a, say, for example, I am using a Flipkart for ordering online something. They generally have a sales, right? And on the sale, they sell item on lower price or with some discounts and everything like that. And in that case, there is a demand of consuming the services or APIs for Flipkart as a selling site. So in that case, there will be a lot of load on the underlying infrastructure where they have deployed their Flipkart site, right? So this particular facility will help them to improve their performance by on demand or dynamically provisioning multiple virtual machines in the background and supporting the Flipkart service that is deployed right now. So even though there are millions of users logging into their Flipkart account, ordering multiple things, doing the payments online, still that is seamless. You don't understand it what's happening, but underlying this infrastructure as a service on demand deploying the virtual machines as per the requirement and providing the services seamlessly to the end user. That is one of the benefit of having infrastructure on demand. Okay. And like it's as like it says in the third point, it increases the stability. Like I said, you will have a reliable, stable, and easily supporting system, and you don't feel as an end user anything missing on the Flipkart as a website. Everything is running smoothly because in the backend it is managed smoothly. Okay. And maintain operational control. Basically, this last point is if you are deploying your own virtual machine, then you need to make sure that you are managing your operating system. I hope that at least basically covers or gives the message what exactly infrastructure as a service. Are there any questions on the topic? Okay, I think I'll take that as a no and move on. And I know, guys, this is very basic. If you are already from the cloud background, then it's already known to you. But I'm trying to cover very basic so that if somebody is out of the domain, they will be able to understand. Okay. Second thing is a platform as a service. So in a platform as a service, like I shown the stacks some time back for the comparison of on-premises and these different services. Now operating system also goes along with the hardware and basically hypervisor to the cloud provider. They manage the operating system. You don't need to do anything. This particular model is useful for generally the teams, software engineering teams, which are doing their developments for the product or the services. Okay. In that case, they just have the cloud services available as a platform. They just log into their platform and deploy their applications and test it quickly. So this particular type of service is majorly used in the companies where there is a continuous development happening, continuous product features are developed. but in their local infrastructure or on premises, they cannot quickly test it. So this particular service will help them to deploy their newly modified code or add newly added features to their product, easily build, test, deploy, and do the testing there, or right, and that gives them a quick service as a platform as a service, so that they can quickly do the development. The benefit of this is they increase their speed of development, and product development life cycle reduces by timeline, and in turn helps them quickly develop the features and bring into the market quickly. This is generally for the product development companies or software development teams who are doing a services, is a good service as a platform. Okay. And recently, multiple cloud providers also started deploying the database applications as a platform managed services. I'll come to that example on the last point. Okay. And what are the types of services are a platform as a service? Okay. So, like I said, MS SQL Server. Now, Azure directly provides you a MS SQL Server available. You just go and log into your server and configure users on SQL and start using it. You don't need to worry about where the hardware is, which hypervisor is managing it, and on top of what operating system it is running. You just got the platform, you just go and use it. Similarly, the web applications, right, on Microsoft Azure Cloud. That is also one of the platform services. Then, if you consider example of relational databases or like that, right? So Amazon provides those kind of services as a platform service. You just subscribe to Amazon RDS service and start using it. That's all. They provide everything underlying. You don't need to worry about. Similarly, the case with the Google App Engines. Okay. And the benefits, like I already mentioned, development life cycle becomes faster in reducing the programming timing. That helps them develop the feature quickly. And deployment of the web applications in cloud becomes easy. Previously, you need to gather everything together on premises and then deploy your code or program written, then start compiling, building, and everything. With this as a service, you can easily deploy and start testing. It's like some few minutes job. Just consume the service, deploy your code, and start building and compiling and testing. That's all. And another thing, like I said, it reduces the complexity of the product because you don't need to manage anything in the on-premises. You just consume the service, deploy your product, and reduce your life cycle of your particular product feature or entire product. Okay. Are there any questions on this particular service? Also, let me know if I'm going too fast or too slow so that I can manage the space or manage the pace accordingly. Okay.
No, Ganesh, I think it's going great. It's just that I think people are able to understand everything, whatever you are narrating. So yeah, I would say it's going good.
Okay. Okay. Cool. Thanks. Then I think there is no other questions. So I'll move on. Okay. The third service as a cloud service model is a software as a service.
So
And
Ganesh,
Ganesh, I
when we
think
take
Ganesh Ashwini
Mhm.
is asking if you could repeat the last point on the slide.
last point as in benefits of a platform as a service or the entire platform as a service.
Ashwini, you can unmute yourself if you want to just
Yeah,
ask.
please let me know what topic you want to just repeat, and I'll just explain it again.
I think DB applications.
Okay, okay. So if you look at the services, the third service that I listed here is Amazon AWS RDS, right? Relational Databases Service. So this service is nothing but a direct service. You can I'm not sure whether you use the Amazon Cloud, but if you log into Amazon Cloud, they have multiple services listed in there. Like in the previous slide, I covered EC2. EC2 is basically a cloud computing service, basically. Similarly, RDS here. RDS is a relational database service that you just subscribe to service and deploy the service and start consuming it. You don't need to configure, manage anything related to relational databases. They will have everything there. You just go configure your users and applications as per your requirement and start consuming it. And this recently still I would say 5-6 years back they started the RDS into Amazon Cloud. And to be very frank, I'm not aware of any other cloud. Probably other clouds also might have started like Microsoft Azure for this RDS service. But I think, yeah, it's in the cloud market right now as a platform service. And I hope that answers your question, Ashwin.
She is asking what is Oracle Cloud.
Yeah, I'm going to come to that in a. I have a slide called cloud providers, so I'll
Uh,
explain
I
that
think
question.
I think Ganesh, maybe the doubt is because Oracle typically we associate with a database. I think the question really is that when you say RDS on Amazon and Oracle Cloud, maybe you want to
Hmm?
explain how they are two different things and not the same.
Okay, so okay, as far as I know, actually I wanted to cover that later. Ashwini, I think I'll come to your question later on. Okay, I'll answer your question about this thing, Oracle Cloud in comparison with RDS and Amazon Cloud. Okay, uh, I'll keep that in mind and I'll explain when we come to Oracle Cloud and the comparison. Okay. So software as a service is basically nothing is managed by end user. Everything is managed by the cloud providers. Your entire application is deployed in the cloud and you just go and consume the services over the internet. That's all. And in this case, as an end user, you are not developing anything, you are not deploying anything, you are just using the services deployed by the software as a service cloud provider. Okay, and everything is managed by developers and of the cloud and deployed in the cloud. You don't need to worry about what underlying hardware is, who is managing the application, who is doing the stuff. You just consume the services. And if I am a person who is exposing my software on the cloud as a service, then as a owner of that software, I need to make sure that whenever there are new features or new bug fixes are there in the product, I need to go and push those on the cloud so that those are effective on the actual cloud services, and then people can consume those new features or bug fixes on the software that is deployed on the cloud. Okay, so here you can really relate your real-time applications or real-life applications that you are using, which are actually deployed on the cloud. So one of the application is Microsoft Office 365 that is deployed as a software as a service. I know most of the people use their email and PowerPoint presentation and everything that comes as a package of Microsoft Office 365. Once you purchase a license, everything is managed by them. You just go and log into your account and start consuming the services like email, PowerPoint presentation, and then Teams. I think also comes as a package of 365. You buy the full package. Similar is the case with the Google apps. When you purchase a Google account, that comes with the entire thing like Google Drive and all the applications that comes with the Google are a part of that particular service. And you don't need to worry about where it is deployed, which cloud it is deployed, and you just go and log in and start consuming the services. So for you, it's just a software deployed somewhere which you are consuming. Similar is this case with the Salesforce. This is just an example which are the software as services. Okay. And the benefits of this is you can log into your Gmail, you can log into your webmail, you can log into your Office 365 from anywhere across the globe. You don't need to be in a particular location. That versatility is present in the software as a service. You don't need to worry about. That's the headache of cloud provider to make sure your service is available anywhere you want to access across the globe. Okay. And the another advantage is you don't have anything on your local computer, right? Everything is in the cloud. So there is a very rare possibility, or I would say a zero possibility of losing your data. I haven't heard that somebody lose the data from their mail servers or something like that. But there is a, I won't say a zero, but very less possibility of losing your data. That is the advantage of this. And like I said, dynamically scalable services based on the workload means if a user base increase for Microsoft 365 Office, they'll just deploy the new instances in the backend and start providing the service more reliably and seamlessly. Okay. I Are there any questions till this slide, or I'll just move on if there are no questions? Okay, I'll move on. The next thing is cloud types, and I think everybody knows about the cloud types here. Everybody will be at least heard the name of, and then we can discuss in detail what each cloud type is. Okay. Uh, Before I move on to what are the cloud types, can somebody have an interactive session and tell me? Actually, looks like I am the only person talking and you're not. You're just listening. So, how about you? Tell me the types of clouds that are present.
Is it something to do with the on-prem, Ganesh? I'm just give it a try.
Give it a shot. Let's
Yeah.
discuss. I want to have an interactive session. So let's see. Okay, you're
So,
saying on-prem is one of the cloud type. Okay.
so Ganesh, it could be like, is it like a private cloud, public cloud, hybrid cloud?
Okay, that's correct. Okay. Is there anybody who wants to answer the question? All right, no worries. I'm sorry. Who was the last person? I couldn't catch your name. Who mentioned the
Harsh,
cloud
Harsh,
types?
Harsh, Harsh.
Okay, Harsh. Yeah, thanks, Harsh. Those are the basic three cloud types anybody knows in the market. Basically, it's a very basic types, and those are the three. One is a public cloud, then the private cloud, and the hybrid cloud. Okay, so you answered it correctly. So this is generally how you can compare what is public cloud, private cloud, and hybrid cloud. So if you look here, your answer was also correct that on premises. On generally the private clouds are deployed in on premises. Okay, so that's why you see this window covering on premises resources. So everything is within your organization. You cannot go outside the organization, and there is a certain purpose to select a private cloud to deploy in on premises that we will discuss in future slides. Okay. Then there is another type called as a public cloud, which is off the premises and accessible to everybody over the internet. Okay, but there is one more type that is called as a hybrid cloud, which is a combination of both of these two. And there is a reason as well to have a hybrid cloud present right now in the market. I'll explain that as well in the next slide. So before moving on to next slide, I think at least you will understand where the private cloud is used, where the public cloud is used, and what is a hybrid cloud. That is a combination of both on premises and off premises resources. Okay. I don't think there will be any question because this is very basic explanation of clouds. So let's move on to detail of each of the cloud. Okay. So what do you guys think? What does exactly a public cloud will be?
Maybe something like all the types you explained, like AWS, GCP, and Azure, wherein they are not
Mm-hmm.
on premises, they are kind of off premises. So they would act as a public cloud for any company or organization.
Mm-hmm. Any other question answer?
Um, Maybe I think wherein the clouds are basically uh, uh, shared. I think it's a shared cloud wherein all the clients are using a shared cloud.
Okay, okay, that is a partially correct answer.
I think anybody can use any cloud.
I'm sorry, your voice was a little bit low. I couldn't hear you.
Pu- Public cloud is basically, the customer does not have a control where my virtual machines are, where my storage is, where my network is, and the cloud provider
Mm-hmm.
determines the location of that.
Okay,
This
so
is
okay, that's correct.
unlike the on-premise,
Mm-hmm.
where on-premise the property, that building, that area is owned by the company, where in the public one, cloud provider decides that I'm going
Mm-hmm.
to have, let's say, for example, the US East or the Europe or the
Mm-hmm.
India region, at what location I'm
Mm-hmm.
going to provide the services, and the customer just has to use those services from the provider.
Yes, yes, that's the correct answer. Thank you. Okay, so I think we covered the most of the part, but I'll go through the slide and let's see if there is something new that I have put in. Okay. So public cloud is basically resources. Every resource like storage, compute, network is owned by the cloud provider. They deploy the data centers in, like somebody said, across the globe, right? It doesn't matter where it is, US East or US West or some other UK region or something like that. They have deployed their data centers across the globe. So those are owned by them and they provide that service. The thing is that in a public cloud, OS, infrastructure, network, and storage and hardware, everything is managed by them. We just need to consume the services. And like somebody already said, this is a sharing of resources. So that was like as when I said it's a partial answer. That is correct answer. That public cloud can be shared by multiple organizations because public cloud also provides the facility to segregate within the cloud itself. So one organization and cannot be talking to other organization, and they have that facility of segregating the multiple organizations from each other. Also, they provide a facility if two organizations wants to talk to each other. So that level of versatility they provide, because of that sharing of resources is easily possible and available in the public cloud. Two big companies can communicate to each other or can completely segregate each other using this particular functionality of sharing of resources across multiple organizations from the public cloud. Okay. And most of the, if you know, most of the office applications, like I said, Office 365 and web-based mails, like Outlook is one of them. All those services are generally deployed in public cloud. That's the reason you can access your mails through your mobile phone device or iPad or note or some other services like laptop, computer. You go anywhere in the world, just go and start using the Outlook, and it will automatically connect to a public cloud server of your email server and start using the application, right? So yeah, everybody answered the correct answer. So yeah, thank you for your answer. And this is what the public cloud is. And the benefit of this is, generally, I'm not sure whether how many clouds you guys use, but I am using a cloud since last 10 years, and I have seen that the costs are reducing recently. Since people are moving to cloud, most of the application and most of the companies deploying their services on the cloud and removing the headache of managing on premises hardware. The cloud also started reducing the charges on their services. That's why I put that point of lower the cost. People get rid of hardware in their on premises, and managing and everything is gone. They just need to go and deploy their services on the cloud and start consuming. That's why that point comes in as a lower cost. No maintenance, because you are not going to go to your lab and do anything. Everything is managed by cloud providers. So you just go deploy your service and start consuming it. Near unlimited scalability. This is like I gave an example of Flipkart some time back, right? When lots of users or millions of users start purchasing the items during the sale days, right? Amazon or Flipkart have their sales, and people on those particular time frame, people start logging into their accounts and ordering the things online, right? That time, imagine the scalability that is needed in the background, but public cloud manages that everything. And Flipkart is kind of a public service, right? They have deployed their service on the cloud, and cloud manages everything. And it doesn't matter how many service users are logging into that service to consume the service, but it is still scalable and easily used. And reliability, I mean, we hardly hear somebody's site went down, like Amazon services are down or Flipkart is down. We hardly hear that. And even if it happens very very rarely. And even if it happens, they recover it easily, because the region in which their data center for that cloud went down, they just reroute their services to some other data center nearby or close by, so that those services are highly reliable. It's a very rare possibility that you will not have a particular service or website down for more period of time or longer period of time. Okay. Are there any questions or inputs on this slide?
Yeah, Ganesh. So, like you said, that there is a backup and recovery option. So, ideally, it should be costly, right? Because you would need more resources to ensure that if your system is failing, there is some backup and recovery option. Still, why it is cheaper?
Right. So the thing is that when you want to procure hardware for your on premise or your lab for your company, you won't buy it in a bulk, right? So when you buy hardware with a smaller quantity, you of course get a higher price, right? But for the cloud providers, they deploy data center in huge, like they are racks of storages, bigger network switches, and high power computing servers uh, as a back end hardware, right? So they get at cheaper price. So they just assemble it together and sell it at the cheaper price than actual on premises, right? And in on premises, the major headache is to manage. If something goes down, you need to go and check everything. Nobody is going to come and fix the problem for you. But in case of public cloud, you don't need to worry about. If underlying hardware fails, they just reroute their service to some other nearest data center or nearest location, so that your service is still up and you're consuming a different hardware now since the current hardware failed,
Got
right?
it.
So
Got it.
it's a shared responsibility, right? It's not like
Right.
that, like all cloud company will manage my cloud, right? Because
Right.
let's say, for example, if I roll over my new instance, EC2 instance, for example, right?
Uh-huh,
So patching that instance is my responsibility, right?
Mm-hmm.
So
So
I'm
yeah,
still responsible for something, right?
yeah. So to answer your question, there is a difference when you talk about a responsibility. If you are consuming that as infrastructure as a service, then it becomes your responsibility. For example, you said that you spinned a new VM on the AWS and you deployed some application and it went down. It's still your responsibility to manage it. That's correct. I agree with
Got
that.
Yeah.
But you are consuming that as an infrastructure as a service. You might have your own product, which is you are deploying on some cloud and exposing it as a service to use or consume by the end user, right? Taken now you place yourself at the Flipkart location, right? Flipkart place. Flipkart is doing the same. They are using infrastructure as service, deploying their services, and whenever there is a change in the product or adding a feature, they just push their feature to the cloud services, right? And end user automatically see the changes in UI. You might have seen the Flipkart application, mobile application getting changed. That is because they are pushing their changes to that. But they are using infrastructure as a service. If you take an example of Office 365, do you really need to worry about where the Office 365 is located?
Yeah, I agree. Yeah.
Right?
Yeah.
So
Yeah.
that is a difference. I hope that answers you or clears the confusion.
Yes.
When you are
yes,
using it as infrastructure as a service, yeah, you need to manage because you are owner. When you are using it as a software as a service, you don't need to worry about. The cloud provider's responsibility or headache is to manage that service. Okay?
Yeah. Okay.
Cool. Thank you, guys. If there is no other question, I'll move on to the next slide. Okay. The next part is a private cloud, and there is a purpose. Basically, public cloud is all good to use because you can access it from anywhere. But there are certain organizations or certain things which really need a restricted access on it. Take an example of bank. You cannot have your servers on the cloud, right? If someone hacks your bank application or someone hacks your backend server, everything is screwed, right? They can change anything in the server, right? So certain business applications or certain organizations which are related to financial transactions, they generally prefer to go to the private cloud. So that's why the private cloud is. So basically, private cloud codes are restricted to the organization levels only. Physical data center or third party deployment with restricted access, and that is a purpose because like I said, sharing is not allowed at all because when finance is involved or business application is involved, financial business application I'm talking about, nobody will allow you to share the resources with anybody else. That's why the private cloud concept comes in. And the advantage of private cloud is you can do the deployment and customizations of your application as per your requirement because nobody is sharing it and nobody is consuming the services of a public cloud like AWS or Azure or GCP because they have certain infrastructure built on their own. You cannot change their underlying architecture of hardware. But in case of a private cloud, you have that authority or you have that permission to change it because it's related to only your organization. You can change the UI, you can add extra hardware, you can remove the hardware, you can add new switch, you can add new routes because that is under your control. That's why customizations are easily available and can be done and managed by you. Uh, as in, when I say you, that is a private cloud provider. You don't need to be an end user as all the time. Okay. And
So Ganesh, does that mean, like, for a financial company who is trying to build their own private cloud,
Mm-hmm.
That means, in turn, they will build something like AWS or like GCP or Azure, but
Mm-hmm.
only for their own purposes and only
Yep.
for their own users.
Yes. Yes, that is
Uh,
correct. But I'll just add one point to what you said. The whatever you said is correct. They will build something similar to the all the public cloud providers on their own and manage on their own. That is correct. But the thing is that I'll tell you an example. I worked with one of the private cloud.
mhm.
The thing is that they don't need a scalability, right? They know the end user is restricted. Like certain people are going to access that cloud, right? So they know. For example, banking, even though everybody has an account, nobody all it's never possible that all users are logged in at the same time, right? So that scalability that public cloud provides probably might not be needed by the private cloud. So I'll tell you an example. I worked with US government agencies, right? Department of Defense, and there they have their own private cloud. And there is a need because Department of Defense is something related to their national security, right? They cannot have it somewhere outside. They have to have a very restricted access. And I know they need really a chip card on which they generate a code every time to log in. So it's like a government agent has a card with him. Every time it generates a token, and you need to put in that token to log into the cloud. So they every time tracking the end user's activity. Whoever is the user consuming the cloud services for the private cloud, they have the token. So government knows who is logging into that particular service. If something happens through that ID, that person is responsible for that. And government agencies and critical business or financial businesses need to have that kind of restrictions. I mean, everybody will agree with that, I think, right?
Yeah, yeah, that makes sense. So, one question.
Mm-hmm.
Um, if they usually do not need the scalability,
Mm-hmm.
and everything is owned by them, managed by them,
Mm-hmm.
then why can't they use the distributed networking and rather go on a private cloud, which might be a huge cost to start with to build a private cloud?
Mm-hmm. So generally, I'll tell you one of the examples I have in further slides is, but I'll bring it here. So private cloud is nothing but they are using the open source application to deploy a cloud and build on top of that. So I'm not sure whether you heard of a cloud stack. Cloud stack is one of the cloud which can be used as a private cloud. So initially, CloudStack was open source. Later on, it is acquired by Citrix, which is a networking company, but they acquired to have come into the cloud area, so they acquired that. But initially, CloudStack was an open source cloud. So what does that mean is you have a base layer with you as a cloud stack. Okay, you take that and you customize it as per your requirement, as per your organization's requirement. So your headache is less than starting from scratch, right? So there are some open source clouds which have an underlying base ready. You just take that and on top of build the security and the requirement of your organization. That is nothing but a customization of the open source cloud, right? So to answer your question, you don't need to really have to build the cloud from the scratch in case of private cloud. You can use some open source services and add security and a customization as per your requirement. I hope that answers your question.
No, I agreed on that point. There may be multiple approaches, either do a scratch or get something which is already available and build top of that.
Mm-hmm.
But the question is more on why do they really need to go on a private cloud? Can they not just use distributed networking if they anticipate no scalability and only for their internal users?
Mm-hmm.
Can they just not use the few of the cloud benefits are like high availability, right?
Mm-hmm.
Now we are saying for the private cloud they are not keen on the scalability.
Mm-hmm.
So
Mm-hmm.
high availability is one point, and then the redundancy, right? So
Right.
can they not just use the distributed networking to make sure that their services would be available in all the regions where their customers are or where their users are, internal users are,
Okay.
and instead of spending money on the private cloud, uh,
Mm-hmm.
just use a high scale distributed networks and make all the services highly available rather than building the private cloud.
Yeah.
Wh-
Okay.
wh- like what drives them for the private cloud?
Yeah, I understood your point. So probably I need to be more clear on the private cloud. If you're thinking private cloud is only a particular data center, then it's not the case. Okay. Now you consider government offices, right? There are multiple government organizations and multiple government. They cannot rely on a single cloud, private cloud, right? So yeah, like you said, they will have a distributed network, but restricted access. The main priority here is the security on the cloud, nothing else. Because the organizations or agencies, those are going to be on that cloud, are secret, are secure, need to be secure. That is their priority. So yeah, private cloud it cannot be only a single data center. It can be across the globe, connected by multiple networks at multiple level, but persons who are accessing that will be restricted. Basically, security will be maintained. So the point that you are putting that it will be a distributed network. So it is already a distributed network. It's just that with the restricted access.
Maybe I can add something,
Sure,
Pramod, to
sure,
this.
sure.
So Pramod, it's also, I mean, from a capacity and scaling perspective, right? It is also to some extent, I would say, being able to scale across applications. So, like Ganesh said, it may not be that your, say, your internet banking application has a surge, but imagine if you have to actually procure something, right? If you go through that cycle and say that, okay, now I'm coming up with a mobile app and I need to procure 10 servers, install Linux on it, get
Right.
security done through it, do the networking, make sure it has failover, it is behind a firewall, it has DMZ, all those things, right?
Right.
So you as a developer or a application team will struggle. So the private cloud is also helping individual applications to kind of quickly deploy while within the same within the bank's security, or in this case say the government institute security. So you may not have scalability issues like that, but to if you've ever worked in a like a very large enterprise, right, you realize
Right.
that getting infrastructure is a challenge. You might be able to develop your code in 2 weeks, but somebody
Right.
will say, okay, your box will come after 6 months, right? So it's also addressing that to a great extent.
Yep. Thank you, Atul, for adding that. Yep. Probably, I'm not sure. Was it a promote? So
Yeah,
does
yeah,
that answer your question?
yeah. To a certain extent, yeah.
Okay.
Thank you.
Cool. Yeah. We can also have a further discussions at the end of the session. It's okay. Okay. And these are just.
Ganesh,
Sorry. Go ahead.
so sorry to interrupt you, but I just wanted
No
to
problem.
be sure that means acquiring the private cloud is just buying the resources from any of the cloud servers like Amazon or Google Cloud and just maintaining by
No.
ourselves, is it like that?
No. So, like I gave you an example of a cloud stack, right? So,
Yeah.
generally, we don't come across the private clouds. The people who interact with the private cloud are the people working for government agencies or large financial organizations, right? Because they need a restricted access. The reason we are probably less aware of it, I will not say not aware of it, less aware of it because we don't interact with it. So any government employee will have to put the access card or put some code they get on their mobile device or something, because that is registered and tracked every action of the individual on that particular cloud. So to answer your question, no, private cloud cannot be on the cloud services like AWS or Azure or some other cloud. I hope that answers your question.
That's right, but I'm just confused regarding the resources. Means how they make their own cloud. Means they bring up all the
Okay, so
resources by their own
so so
money.
so to add to that, Ganesh, I would like to maybe add one more point. Probably
Sure, sure.
that may help him. So
Mhm.
this is it's not about buying or renting or leasing
Right.
the resources from any of the public cloud providers. This is building your own cloud. That means and before that I would also like to add. So basically, what you are doing is you are not going away with your compute or storage or the network, the one that Ganesh explained in the initial session,
Right.
in the first session, right? So basically, all your network devices, compute devices, all the storage devices, they will be there. Okay. However, now you are buying in bulk for your own
Right.
organization. So, if, for example, the U.S. government or the major financial services, they buy it in bulk so that they can get this advantage of the cheap option, like instead
Right.
of buying say one cpu, they are now buying 1000 cpu, and so they can negotiate the rate, so they will get that benefit. And I have worked with some of the very large financial organizations. They were
Mhm.
thinking of the private cloud implementation or the hybrid cloud implementation, and there were
Right.
two purposes. Okay, one is obviously the restricted access and the data. And
Mhm.
the second one is basically currently they do not know what this Amazon or Google or Azure are going to do with their own data. If because
Right.
nowadays
So
it's
yeah,
like
I'm going to.
every
Right.
company is
I'm
a
going to
data
come to
company.
that point. I'm
Yeah,
going to
sorry,
come to
sorry,
that
Ganesh.
point in a
All right, okay.
hybrid cloud. So
Yeah.
thanks for adding those points. I really appreciate your information. I hope somebody who was asking question got what he wanted.
Yeah, yeah,
Right?
yeah. Yes.
Okay.
Okay.
Cool. Cool. So in the hybrid cloud, like I'm just adding continuation of what I'm not sure who Pramod was that, I think, right. So I'll just continue to that. So hybrid cloud is nothing but a combination of public and private cloud. Like he said, he worked with some organization which has been thinking on this. So they definitely will go for this, I would say, right? It allows user to consume the features or functionalities of both the cloud. So for example, certain applications of organization don't need to worry about the security much. They can just go and deploy the services in publicly, right? To consume by the end user. In that case, they can use a large number of virtual machines and instances on the cloud and deploy it because they are not much worried about the security, right? So those kind of features of public cloud will be used by the service provider and end user can consume. But same organization can have their finance department or certain sensitive applications which cannot be exposed to end user, right? Or cannot be exposed, right? So in that case, they will go for a private cloud. So for such kind of organizations which have services, both can be going into public cloud and private cloud. Hybrid cloud is the best choice for them. Basically, they can use the features or functionalities of both the clouds together and still run their organization, and making sure the critical or security related applications are running in the private cloud and public related or public facing applications are running in the public cloud. So one quick question. I'm not sure, Atul, how much time I have, but let me know if we are running out of time. Okay.
Yeah, I guess we can continue for a bit if
Cool.
everybody okay with it.
And if other people, I'm going to ask to other audience as well. Please let me know if you want to stop. I mean, we can definitely continue next session or something like that. Okay. One last question on the cloud type clouds. Do you know what is cloud busting? And I added this specifically feature because it is more related to hybrid cloud. Anybody from the audience?
And there is the additional load, which is which cannot be handled or not means what we can say organized or managed.
Mhm. Okay, okay. So I'll explain it a little bit more. Your answer is partially correct. Okay. So I'll answer it a little bit more. Cloud busting is basically, for take an example like organization I explained just earlier. It is consuming services of both public and private cloud, right? They definitely know that private cloud has been deployed locally in their somewhere data center or in their office itself if their organization is smaller. Okay, and they are consuming the private cloud services, and private cloud services are provided for both security concerned applications or business or financial related application, as well as some of their services which are less security concerned, but still they want to use a private cloud because public cloud is comparatively higher cost than the private cloud. So generally, most of the companies try to have their services most of the times in private cloud first, but they give priority to the critical applications or business or financial application on the private cloud. And if still they have resources left on the private cloud, then they will deploy some services on the private cloud itself. But certain times it happens, a lot of millions of users go and connect to your applications or services, right? In that case, there might be a load on the infrastructure, right? And to manage that load, you can configure your hybrid cloud in a way that it will on demand deploy the virtual machines or instances on the public cloud and shift your less critical or security, non-security concerned applications in the background to the public cloud and still give the seamless service. So that is nothing but the cloud busting. When cloud busting is detected in the hybrid cloud, less critical applications or less security concerned applications will be shifted in the background automatically to the public cloud, and making sure your sensitive and financial critical applications are still running in the private cloud and both the services are running smoothly. That is nothing but a cloud busting, handling of a cloud busting. Okay.
Yep.
Okay. And benefits are pretty simple. Since it is a hybrid cloud, it's combination of both. You have the user control for the private cloud, and public cloud is account used by you. Flexibility because you runtime decide. Cost effective because as compared to private cloud is cheaper. So you are most of the time keeping your resources on the private cloud, but when required, just go and deploy on public cloud. So you are managing your cost effectively, basically. And the last point is just I explained, easy to use based on the need, like on demand. On demand, you go and deploy on the public cloud, less concerned applications. Okay. So, okay, I'll just cover these two parts, Atul. I know we are running out of the time, but I think we can cover this. Basically, this is just an information, nothing to discuss here. The my cloud providers, which are highly recognized currently in the market and used by most of the companies or the organizations or the government agencies. Okay. First of all, AWS is there from longer period of time, I would say. I mean, I also started my career working on AWS itself. That was the only cloud that time famous and used across the globe. Okay. This is 10, 12 years back. Okay. AWS. Then Microsoft recently took a market very huge and they started very good in the cloud domain, right? So this is another cloud provider. Google Cloud Platform is basically more focused on machine learning and AI, right? Artificial intelligence. So they are more focusing on that and developing their cloud on that direction. So these are very huge cloud providers, but they have different aims and different goals, right? Based on that, they are still doing good parallelly in the market, even though they are sitting aside each other, right? IBM software is one of the older clouds, but they are still developing and improving more recently in the IBM on the IBM company itself. Okay. Then, yeah, Oracle Cloud Infrastructure. So I think I forgot the name. Ashwini or someone had a question on this, right? What is OCI or Oracle Cloud? So recently, Oracle company started their own cloud called as Oracle Cloud Infrastructure, and it is almost similar or analogous to all the current cloud providers. And when I say recently, it's not that recent. They started their cloud in 2016, but they are still growing in that pace. Okay, and they are still in the race, I would say, but still not meeting the expectations along with other clouds like AWS, Azure, and that. And when you said about the databases, so I wanted to distinguish there itself. There are two types of databases people use in the market. One is MS SQL, that is Microsoft's SQL Server, and Oracle has their own database, right? Oracle DB. Okay, those are two different applications. The application which I was talking earlier in the previous slide was related to AWS and MS SQL for Microsoft Azure Cloud. That is MS SQL Server application I was talking about. And the question you had was about the database services. So database services I was talking about are RTS, like relational database services provided by Amazon. And the question you had was related to Oracle database services. Those are provided by this cloud provider, OCI. They have their own templates already present in their cloud. You can go and just deploy the instance and start consuming the Oracle DB services. I'm not sure whether you use the Oracle cloud, but they do have that facility there. I hope if she is still on the call, she got the answer.
Yeah. Thanks.
Okay, cool.
So every cloud has their own native cloud applications.
Applications. Right, that's correct.
They are good.
OpenShift and everything, all that Kubernetes and all that stuff. Lots of cloud started providing direct templates, deploying that services inside. You just go and deploy the template and you start consuming the services. You don't need to worry about how it is configured and all that. But they also provide the option of customization. If you want to customize that service like Kubernetes or Docker or something, Red Hat basically acquired by IBM, but they still provide the containers on their own, Docker containers. And they have most of the services already deployed inside. You just go and consume the service. That's all.
Okay.
hmm And these are the two cloud providers I was talking about. This is still open source community, OpenStack. They keep on developing their software backend, and companies can use to host a private cloud inside their organization by using OpenStack. I'll give you a small example of this. Basically, I have a company of say 250 people, okay, and I am working in the cloud space, right? So for my product to test, I need multiple virtual machines at a time, runtime. But my company is smaller in size, so I cannot go for the cloud services, right? Because that are costly. So what I can do is have say 25, 30 servers rack with me and deploy OpenStack cloud as a private cloud on that, and allow people to create virtual machines on the OpenStack itself, so that my organization people like 200, 300 people can directly consume the services. I need to only procure the hardware once to manage the cloud, right? So that way I save the cost as well as my people could get the product testing done within the private cloud itself. So this is one of the examples. Okay. Cloud stack also the similar lines, but government agencies also underlying use the cloud stack as the basic, and then on top of that they build their customization to have that a government cloud as a private cloud. Okay.
Yeah, Ganesh, but who owns this OpenStack and CloudStack? Is there any company behind them or?
No, OpenStack is open source community kind of stuff. CloudStack was open source as far as I know till 2016 or 17, but recently Citrix built their own custom cloud stack. I mean, they took the open source and built on top of that, which is very good in the market. So they claim that they own the cloud stack V2 or something like that. I mean, the second version or something like
Okay.
that. Okay.
Yeah, I think CloudStack was Apache initiative, so maybe
Right.
still open.
No, no. See, there are two parts. Like I said, Citrix took it and on top of that they built their own something and they claim that this is ours. The open source is still open source. You can go ahead and use it. But their cloud took too much boom, so nobody really goes to the actual open source cloud stack yet, right? That's what I was
Correct. Yeah.
So, in the interest of time, can we do the last slide if we are going to
Okay,
cover?
sure.
Correct.
This one
Just
is
going before going to last slide, can I ask
Sure.
some few questions?
Yeah, please go ahead.
So as I'm new to this cloud technology, I'm just asking that if any company wants to establish its own cloud, right? So whether that company needs to use any of the cloud services like Amazon or Google or Microsoft, or it's how the establishment of cloud is done.
Okay. So I think I understand your question. So like I gave example a couple of minutes back. If I have a company of my own and only 200 people, but my people need a testing software to be deployed on the cloud. But since my company size is smaller, I cannot really go for the cloud services because of the costing, or cost effectiveness is hampered basically, right? So to make sure that I'll go with someone like OpenStack or CloudStack, which are open source. I know nobody claims it. I can use it. So I will just have an infrastructure or hardware procured within my organization itself, unless and until my organization is going to be like 1,000 or 2,000 people. When I reach to that level, then I'll think of basically revenue will be higher, then cost will be higher and something like that, right? To run the company. So in that case, when scale goes on increasing, I'll definitely go to the cloud that time. So it's all about your cost effectiveness, I would say. It's owner's choice or company's founder's choice to decide where to go. But generally, people will go for the open source clouds initially when their company size is smaller or they are small in the market.
Yeah, that's right. But that's right. But I just wanted to ask that now, as you told, cloud stack or open stack, right? So how the open stack is built means many of the people comes together and bring their resources, bring their softwares along with them?
No. So there is a open source community. They have all the documents publicly available. They also give you the stepwise documentation how to deploy your own OpenStack. Okay, similar to these three basic components I talked about at the start of the session: compute, storage, and network. They
Right.
have the similar architecture underlying. They also have a compute. They called it as a Nova compute. Then they have a network. They called as a and they have a storage, right? The Neutron is for network management. Compute is managed by Nova Compute, and then there is third one called as storage. They generally called it as Cinder and keep on evolving around that recently, right? So they have everything open. If you want to consume OpenStack or if you want to deploy OpenStack, you just procure the hardware on your own. No need to share anything, and that generally works for the smaller organization or the organizations with the very security restricted access. Is what I think.
Okay.
Okay.
Yeah.
Guys, I'll share the slides so you can go through this. I don't know whether slides are self-explanatory, but this is more dig deeper how underlying cloud works. But let's see. In the interest of time, I'll just go with the last slide. Okay. Current cloud market. So this is not prepared by me. I just copied it. You also see the source below. But this is the current trend going in the market. Okay. You can look at the technology and you can look at the growth in 2019 and 2020 based on the services, right? And the cloud providers which are top right now in the market. So if you look at the first box at the top, AWS still is running the show, I would say, right? In 2019 statistics are there, but you can look at their revenue and they are still on the top. But Microsoft came in later on in the cloud, but they are still, if you look at the growth rate, AWS growth rate is 41% and Microsoft quickly acquired it to 75%. And Google also came a little bit late, but they are also catching up. And if you look at the growth rate, it is 83% or something, right? So these two guys are going to give a tough competition to AWS in the market. This is a 2018, 19, and 20 statistics. And if you talk about the platform as a services for the top growing cloud, then these are the basic services currently very valuable in the market. One is IoT, right? Then there is a container, like I talked about Kubernetes and Docker. So that is nothing but a container service people started giving out. Then ML and AI, machine learning and artificial intelligence. Google is basically behind it most of the time. Data warehousing services and serverless is basically you don't need to worry about anything. Your application is already managed by the cloud provider. And you can see the growth graphs in 2019, 2020, and the percentage growth within those 2 years. Nothing to explain here, but just giving a gist of what's going on currently in the cloud market.
Good one, Ganesh. Thank you.
Okay. Are there any questions? I'm going to share the slides so you can go to this and understand. There are only
Yeah,
slides.
I think Ganesh, we can maybe schedule one more session subsequently to go through the virtualization bits in detail. Maybe if people are interested, and that might be a
Yeah, we
good
will
way to-
That
look at
really helpful.
Yeah, I mean, whatever we
Yes.
discussed is on a actually what exists, but I think the core concept, Ganesh, we can have one more to understand how it works actually underneath.
Okay. Okay.
Yeah, maybe
So-
we can do a demo or something next time to maybe look
Yeah.
at it.
Okay.
Om and Ganesh, if possible, then we can schedule it tomorrow or whenever.
Okay.
Actually, we do every Saturday. Okay, so
Okay.
I will have to convince Ganesh because he's very busy man. So I'll try my best to convince him for the next Saturday in like same time, same place, and that would be the I would
So,
say.
Divnesh, also what you can do, we have that website, right? I have sent you the link, and Om will maybe, if we can spare another 2-3 minutes, walk through the website. You can try and book some 1 hour session with Ganesh, which is one-on-one, and he can give you like a basic overview of it also.
Okay, that will
Yes.
be really
So
helpful. Yeah.
let me talk about that. So Atul, can I start? Ganesh,
Yes,
can
yes,
I
please.
share my screen because we are already out of time? So
Yeah,
yeah, Ganesh, you need to stop sharing. I can share,
yeah.
but I don't want to.
Guys, I would request you to just bear with us for. I know we are like grossly over time, but just bear with us for 2-3 minutes. We will kind of explain what the platform is, so that if you want to kind of, like I said, follow up one-on-one with Ganesh or somebody else, you can do that. And yeah, so just bear with us for like a minute or two. No.
Yeah, so I would say thank you so much, Ganesh, for taking out time and conducting this session. It was really helpful for me as well, and I'm sure for others too. So, guys, thank you all for joining. So, briefly, I'll explain what this platform is about. So, basically, we started this platform during pandemic. So, basically, we wanted to create a virtual place wherein people can connect to each other and they can learn from each other. So, and where you can actually share your knowledge, expertise, experiences with others. So for that, actually, we have three formats. So like Atul explained, if I want to talk to Ganesh, I can set up a one-on-one discussion and discuss more about cloud. This is the webinar which you just kind of participated. And the third category is open discussion. So we kind of pick up any topic, we invite a few subject matter expert, and then we have a discussion around it. These are the certain topics which we have started with, and you would find the mentor's name under each topic. You can click on the mentor and it will redirect to their calendar so that you can schedule one-on-one. Okay, so these are a few mentors who have agreed to donate a few few hours in a week wherein you can go and talk. So for example, if I want to talk to Ganesh, I can just click on this link. It will open up the Ganesh calendar wherein I'll get to see that when he's available. And let's say if he's available on 19, I can just click on the date. I can choose a time which works for me. I can confirm. I can just give my name, email, and I can give a brief of what I want to discuss, and then my LinkedIn URL, so that Ganesh would get to know about me a little bit. And then this way you can schedule your event and you can talk to Ganesh one-on-one to know more about this cloud, how it is done, and if you want to learn more. If you think that this is something interesting and you want to join us, then you can use this link to register yourself as a mentor, and you can become part of this community, and you can also share your knowledge and expertise with others. You can also conduct webinar. You can donate some time wherein we'll set up your calendar so that you can talk to mentees one-on-one and help them, guide them, if you have any queries, if you see that you wanted a mentor which is not here, you can please write to us and we will make sure that we'll try and find the right mentor for you. Uh, if you want to know all the mentors, so basically you can click on this button. We are using Calendly to manage the calendar of all of our mentors. So here you will see all the mentors who are donating time, and if you click on their uh, calendar, you get to see little bit of detail of brief what they are doing and how they can help you with. So that is also there. Also, like we don't push emails for the registration process. So basically, we use your email just to share the recording and the slide. But if you want to know what would be the next topic next week, then you can follow us on any one of the social media platforms. And there we post every week what would be the next topic, what would like registration link, etc. Also, we are recording all the sessions, so we have a YouTube channel. Please go and subscribe, and you will get a notification. And basically, you can go if you are busy or by some reason you are missing the webinar, then you can go and always watch it later. We are always open for any suggestion or feedback. So I think Atul has already shared a link for the feedback.
Yeah.
Please kind of fill that and feel free to give us any suggestion you have. So that's it,
Yes.
Atul. Yeah, over to you.
Yeah, just to add to what Om said, so the entire initiative is, it is non-profit. So even the one-on-one sessions are free of cost. There are no, like, there is no monetization aspect at all. Everybody is donating time, so feel free to use it. Like I said, I mean, there is no fine print, nothing. It's just completely people donating their time and expertise. So we would really appreciate if you can just follow us on one of the social media platforms and YouTube specifically. That will kind of help us spread the word. But other than that, there is no monetization at all on this. So please feel free to reach out to people on the platform if you want to kind of discuss something one on one with them in whichever area. So there are multiple topics there, from ML to cloud to API development, testing, and also non-IT related, mental health, physical health, yoga. So see what you want to, and then you can connect to people there. Yeah, I think that's about it from my end. The feedback link is in there. If you guys can go and submit some feedback, that will help. That's about it. Ganesh, thanks again. Thanks for the session. And thanks, guys. So we'll close the webinar with this. Thank you.
Thank you, everyone. Thank you for attending.
Ganesh and entire organization team. No, thank you. It was really a nice session, and I really appreciate everybody's efforts and time here. Thank you so much.
Thanks, Pramod.
Thank you.
Thank you, everyone. Great learning experience.
Thanks, guys.
Thank you.